All right, so let us continue on our astronomical voyage. Sharing the screen here. This class is about the five wonders. There are actually seven wonders because the sun and moon are often included, but their movements are different enough from the other five that we have pulled them out of this class. And we had the last class where we talked about the sun and the moon. Here we have a celestial sphere from the 11th century. We've got the Earth in the center, and outside, then we have the circles of, starting from the farthest out, you have Saturn, Jupiter, Mars, you have the ring of the sun, Venus and Mercury, and then you have the lunar sphere closest to Earth. So we kind of see this same celestial outline that we've been looking at. By now, I don't think we have any new participants. So no, it's just the same four of us. So I'm not going to go through this, just remind everybody that at my website down below, I have a lot of good bibliography type of information that you might find useful in the future. So the seven wonders are planets. We have the moon, Mercury, Venus, Sun, Mars, Jupiter, and Saturn. Planets come from Greek words, planetes, asteris. My Greek is not that good, but it means like wandering stars. And oftentimes they're just called the wanderers. They are a different classification than like the background of stars in the distance. And of course, they are the ones closer to Earth. We have dealt with the sun and the moon in a previous class, and so this time we're going to deal with the other five. We might think about Saturn. It has the Greek name here, Thananion, which means shiner. The Greek god associated is Kronos, and the Roman god, which is the name we call it, is Saturn. Jupiter, with the Greek god Zeus, the name being like Thation, which means bright one. Mars, Greek god Ares, the word Phyrosis, meaning fiery one. Venus, the Greek god Aphrodite, and the Greek name would be like Phosphorus, which means like light bringer. And Mercury, the Greek god Hermes, which means, and the Greek word stillburn, which means like gleamer. We see another illustration of the planets here from around the 9th century. This one uses figures to depict who they are. And you can see here in the Earth, and then we have, the lunar ring and Mercury and Venus and the Sun and the other three planets here all represented. And you have the ecliptic on the outside, just kind of to keep us glued into that perspective. Now we're dividing up the heavens. We still are using our celestial sphere. We have the Earth in the center, and then outside of our celestial sphere, we have these rings. And we imagine these rings and use these rings for calculation as well as just for a teaching tool. So we have the ring of the ecliptic, which is the sun's path around the Earth. The moon and the planets also follow the ecliptic. And then you have the equator, the tropical circles, the Arctic circle, and the prime meridian. This is kind of like our skeletal structure of the Earth. We call it our Mecury sphere, sometimes a celestial sphere. We looked at this picture before, but it's even more useful now. We see the Earth at the center, the elements around the Earth, and then the very next ring, we have the moon, the ring of the moon's orbit. Then we have what we will soon learn are the inferior planets, Mercury and Venus. Then we have the sun's ring on the outside of that. And we have the greater planets, Mars, Jupiter, and Saturn. And around that, we have the sphere of fixed stars. And that gives us our Ptolemaic system of the universe. Again, this is a flat one that shows us a brighter picture of the individual circles the planets rotate on, but it's good to keep this perspective in view. Now we should talk a little bit about planetary motion, which is kind of what we're talking about the whole class here. This might end up being more dense in the beginning with more pictures to try to illustrate the concepts we've done at the end. Planets mostly move eastward around the ecliptic. The ecliptic is also called the zodiac. It's the sun's path, and the constellations might move slightly or the planets might move slightly off the ecliptic by around 9 degrees for Venus and around 2 degrees for Jupiter. But for the most part, the planets follow an eastward motion on the ecliptic. Planets go eastward, but they also reverse every now and then. The eastward motion of a planet is called prograde motion, and the reverse motion of a planet is called retrograde motion. All the astrologers like to talk about retrograde motion, especially when Mercury goes into retrograde. You know that's when all communication and everything is supposed to break down. So they always like to talk about this motion, this retrograde motion and prograde motion, and this is where it comes from, whether the planet is moving eastward on the ecliptic or it's in reverse. Sometimes when a planet begins its retrograde motion in the heavens, it appears to stand still, and this is called its station. We talk about two different planetary periods, most likely like we did with the sun and the moon. We have a tropical period, which is the time it takes for a planet to travel the ecliptic once, and a synodic period, which is the time it takes between retrograde motions. And these are often vastly different periods of time. Now, let me just check in the chat real quick to make sure all of you are okay. If there's any questions or comments about anything that I may have mentioned. Probably not, and or if it is, I'm very sorry because oh, there it is. Those last two terms. We're talking about retrograde and prograde. Yeah, I can explain that a little bit more. Let me get out of my screen share and pull up my celestial sphere here. So the ecliptic is the path of the sun. It's roughly here. And in the sky, the planets always appear to be moving, for the most part, eastward around this. But occasionally they have a backwards motion. So the sun is moving eastward right now when I'm moving it, but the planets occasionally appear to go backwards. And then they go forwards again and continue along the equals, and then they go backwards, and then they go forward again, and then they go backwards, and then they go forwards again. When they're going forward, they're called what's going prograde, or their forward motion eastward along the sun's path is called prograde motion. This apparent backwards movement or westward movement on the ecliptic is called retrograde motion. And so it's very strange that the planets do this, and if you don't watch the planets on a regular basis, you would not know that they do this. I was alarmed to find out that they did this, and I think I was in college when I found out that this happened, and I was reading astronomy a lot in my youth, but no one had ever stopped to mention to me that the planets did this. Now, the reason they do it modernly is different from the reason we thought they did it in the medieval period, and so a great deal of what we're going to look at today is trying to explain why the planets appear to sometimes stand still and why they plan to go. But if you imagine the ecliptic as an arc, the planets rise in the east just like the sun does, and they follow the sun's path. And then sometimes they stand still and go backwards, and then they begin their eastward motion again. And then they stand still for a second, and then they go backwards, and then they continue their eastern motion. And then they stand still, and then they go backwards, and then they continue their eastern motion. And so this is the retrograde and prograde motion. At the risk of elaborating too far, did I get that okay? Do we want to continue with it? Do we want to? Okay, good. And so we'll be talking more about it as they continue. So, all right. So we have these two kinds of motion, eastward around the ecliptic, prograde and retrograde. We also know that sometimes when the planet begins its retrograde motion, its westward motion, it appears to stand still for several days, and this is called its station. And we're talking about the two tropical periods, the time it takes to get from one ecliptic to the other ecliptic. For example, if Mercury is in the constellation Sagittarius. How long would it take for Mercury to get into the constellation Sagittarius again? That's the tropical period. And the synodical period would be the time in between those two retrograde motions. All right. Now, I guess we can start talking about the inferior planets. Now, there are two inferior planets. We have Mercury and Venus. These are called the inferior or lower planets because they are closer to the sun than we are. It doesn't denote that they're not as important. Now, in Ptolemy's day, they were believed to be closest to the Earth. There's some historical disagreement about the exact orders of some of the planets, but for the most part, it's Mercury, Venus. Well, for the most part, it's the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn, and that's the most agreement is among that pattern. The inferior planets are defined partially by something called limited elongations. The angular Sun, and limited elongations is the angular distance from a planet to the Sun. The farthest Jupiter gets away from the Sun is 48 degrees, and the farthest Mercury gets raised 28 degrees. The other planets have much further elongations, like 180 degrees. And so the fact that these two planets have these very short distances they get from the Sun is a defining feature in them as lower or inferior planets. Now, these two follow the Sun the most closely. You usually see them either right before sunrise or right before sunset. Mercury is the harder of the two to see because it's the one that stays the closest to the Sun. Venus is often called the morning or evening star. If you've heard the expression, the morning star or the evening star, they're usually talking about Venus because of how close it gets to the Sun, and it's one of the brightest things you can see right before sunset, right before sunrise, right after sunset, right after sunrise. And the topical periods for the inferior planets, both Venus and Mercury, are 1 year. The synodal periods differ, around 116 days for Mercury, around 585 days for Venus. Now, going back to the chat, just to make sure everybody's okay. And I guess it's not going to come up. Alt-H. I'm sorry, I hope to, oh, there it is. That's disturbing, but clear. All right. All right, so back to the share screen. So, then our other planets are called the superior planets. And those are Mars, Jupiter, and Saturn. These are called the superior upper planets because they are on the other side of the Sun's orbit. So you have the Moon, and then you have Mercury and Venus, and you have the Sun, and you have Mars, Jupiter, and Saturn. The superior planets are characterized by something we call unlimited elongations. Elongation of being the furthest degrees. Of course, the furthest degrees you can really get is 180. When a planet is at 180 angular degrees distance from the Sun, that planet is said to be called at opposition. The superior planets often undergo retrograde motion when they're at opposition. Now, if the Sun is on the other side of the Earth and the planets are opposite it, that's kind of the opposition, the 180 degrees we're talking about. In other words, the middle of the planet's retrograde arc occurs when the planet is in our opposition. And I remember I was saying that you could imagine like because the Moon, the Sun, and the planets all follow this ecliptic, the path of the Sun. So they rise in the east and set in the west. So, they do this arc, but because they have the retrograde motion, it looks more like this. The middle of that arc for these superior planets occurs at opposition. The connections with the Sun were known with astronomy of the Greeks and Babylonians. though this was only a fact without firm explanation. So what I'm saying here about the opposition of the retrograde occurring, the retrograde occurring at opposition was known in ancient Babylon. The Babylonians spent a lot of time working on their planetary theory. It was one of their major caring moments. Getting ahead of us here. All right. So, okay, apparently we don't have, let's see here, previous. We need to talk about the case study of Mercury. Mercury has two kinds of conjunctions. A conjunction is when two objects are in the same space. So when Mercury and the Sun are in the same space, we call this the conjunction of Mercury, or the conjunction of Mercury and the Sun. Mercury has two kinds of conjunctions. Mercury has conjunctions prograde and retrograde. So while superior planets all have oppositions and conjunctions, Mercury only has conjunctions, but it has two kinds of conjunctions. So the Mercury synodic cycle would look like this. You would have the prograde conjunction, where Mercury is moving east, but it's in the sun space. Then you would have the eastern elongation, where Mercury would be moving the furthest east it goes from the sun. Then it's going to appear to stand still, and then it's going to go back into a retrograde conjunction. Then it's going to reach its second station, appear to stand still, and then it's going to go into its greatest degree of separation from the west, and then it's going to go back into a prograde conjunction, and it's going to follow this back and forth with the sun, peeking out on both sides of it, as it were. And Venus is going to do roughly the same thing. During the retrograde conjunction, the planet is invisible because it's too close to the sun, the same way with the prograde conjunction. Then Mercury becomes visible during the sunrise. It's there for a few days, and then it has, they call this either the first morning rise or the last morning rise when you see it. Then it disappears for the prograde conjunction. Then it appears at sunset for a few days for the first rising and the last rising, and then it goes back into the sun for the prograde conjunction. This is very important in Babylonian astronomy. So looking at the chat, I've unshared so I can see the screen. There's a lot there about Mercury and how it moves and the two kinds of conjunctions. Does this make sense to everyone? You have questions about motion of Mercury? Makes sense. Okay. Sounds good then. Let's go back. Sharing the screen. All right. Next. So we should take some moments to look at retrograde motion. Here we have the Ptolemaic model as we think of it. The Earth in the center, the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn. All right. We move forward, and we're looking at retrograde motion. Here is an example of what it would look like if you took like several shots for many days in a row and combined them together. I believe this is Mars, by the way. So you have it moving eastward, 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 eastward. Wait, it seems to stay still. It kind of reaches what we would call a station. Westward, 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 eastward, 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 eastward. So you see the apparent motion of a planet in the sky charted out for many days. Now, they explained these retrograde motions mostly through epicycles. And they said that there was a spirit, an elemental, an angel at the center of these epicycles. And then the planet itself, whether it be the moon, the sun, or whatever, would go around that And this is what would create the apparent retrograde motion. It's still proceeding forward, but because we're looking at it move around this circle, here you have it. You see the moon and the sun, they don't have these epicycles because it wasn't needed to explain their motions. But Mercury and Venus have them, and Mars, Jupiter, and Saturn have them. Of course, here we have the background of stars again. So we're starting to, this is how they started to explain what's going on with the retrograde motion, although they don't know what's holding it to the center. Here you can see that again because whatever's holding it to the center is going around this circle. And Mars is going around this other circle, this epicycle. And this is very important to how they kind of decided to set up their planetary theory. Now here, we see it work out. Let's watch this for a little bit. Kind of interesting, isn't it? This is how they followed the mathematics. Okay, pausing to see what's happening here in the chat. Wow, makes sense, yeah. This is kind of how they, illustrated it together. Now I'm sharing my screen again, so you can look at some more pictures. All right, so moving on, we get a different kind of we get two kinds of retrograde motion. The first retrograde motion is this one here with the symbol. You have the Earth with an offset center. Now, today we know the orbits of all planets are ellipses, which means they're more oval shaped than they are circular. But we talked before about having what you would call a mathematic equivalency. An ellipse and a circle with an offset center have what you call a mathematical equivalency. So they couldn't quite get the math right with the Earth being at the center of the circle and these eclipses around the epicycles this way. So what they had to do, what Ptolemy had to do to make the planets work, is he had to offset the center of the Earth from the center of the circle. And that created the accurate motion of the planetary bodies. So we still have the planet moving around the epicycle and the center of the epicycle moving around the circle. But now you have the Earth at an offset center, and you have a point opposite the Earth equally called the equate. And the equate helps us visualize how the balance is maintained for this kind of movement. And then in the second sphere on the right, you see how it works. Now let's go one more, and we watch it happen with the offset center. So we can see how Ptolemy's version of the epicycles worked out. The epicycles mostly worked out for before, but there was just mathematical things they didn't explain, and it wasn't quite right. Ptolemy, who wrote the Alchemist, was the one who finally got the epicycles to do the right math and had it work in this way. All right, going to stop this to check on the chat. Mathematical ellipses, yep. That's exactly how they did it. In mathematics, whenever you have two things that are mathematical equivalency, you're always allowed to choose the more attractive version of them. So for the Greeks who worshipped astronomy in geometry, a circle with an offset center was far more appealing than an oval. And so you can make an ellipse in a different way. So this explains the orbits, and this is how Ptolemy did it. Now, it's very difficult to kind of do these measurements on your own. So there's kind of two different astronomical instruments that were invented to help you predict when things were going in retrograde motion and when things were going out of retrograde motion. The first of these is called Ptolemaic Slates. These Ptolemaic Slates here show it is you have a spindle to choose which planet you're working on, and then it tells you how to do the angle, and so you can create mathematically the motion of the planets with very little information compared to what you need if you're going to do it with trigonometry on your own with this simple tool. And these Ptolemaic slats are explained in the Alchemist, and it's something that was used throughout the medieval period to demonstrate the motions that we saw here in a way that could be used more for prediction, because it does take a lot of trigonometry to do that. There was also something called the Equatorium Martis. The Equatorium Martis was the same kind of thing. It looks kind of like an astrolabe with a back, and there's a string, and then then you have your epicycle, and you can kind of show the movement around the Earth through it. These different types of equatoriums could be done for each of the different planets. This one is specifically done for Mars. These existed all the way in ancient Greece, and they existed throughout the Middle Ages too. And so this gives people a more common way of explaining and understanding, predicting how these epicycles worked. Now this here is a contraption made by Johannes Kepler. Johannes Kepler came after Nicholas Copernicus. Now, if you remember me saying that Nicholas Copernicus was kind of like the last astronomer in the Ptolemaic tradition, because Copernicus basically wrote the Alchemist for the condition of the Earth being the sun being at the center instead of the Earth. Everything else in the Alchemist was preserved. So in the revolution of the heavenly spheres, you still have planets and epicycles and epicenters, and it still uses equates. Everything is preserved the same way. However, the only difference is instead of having the sun at the center, you have the Earth at the center, and he made the math work for that. But Copernicus created a way of trying to use this kind of science and trying to tell the difference of the different spheres by putting them within each other like this, and they call it a Mysterium Cosmographicum. And this picture of it is from about 1596. And so that is actually the material I had planned for this. I didn't know how many people we would have, and I thought there might be more questions along the way than there were. And so I apologize for that, but I do still want to open it up for questions. Do you feel like you have some understanding of how the medieval astronomers thought that the planets moved and how that worked?
You've actually given me something new that I want to research for ANS.
Oh, cool. Very happy about that. There's a whole ton of stuff here, and it gets fairly technical. I was trying to create a presentation of this that would be good for most people who weren't interested in trigonometry. But I know the broken record. Evans, The History and Practice of Ancient Astronomy, goes through all of this in a more detailed way than I do. And then once you get past Evans, you have the Alchemist to deal with. And those of you who want to connect ancient and medieval astronomy to modern astronomy, can you work your way through the revolution of the heavenly spheres to switch from the Earth being the center to the sun being the center. And then there it's just slowly changes until we reach the system of modernity that we get to today.
When did they make the switch of sun being center to Earth being center?
I don't remember the exact years, but I believe it's 1600s. Nicholas Copernicus was a Catholic priest. He wasn't trying to cause waves. And I think he was either late 1500s, early 1600s. But that book, whenever it got published, and it didn't get published till after his death. So he didn't have to deal with the falling out that came because of it. That's when the switch was made. The big revelations come from Kepler, who we were looking at a second ago, who really was pushing kind of eclipse motion, and then from Galileo, who wasn't the inventor of the telescope, but who was the first one to use the telescope astronomically speaking. And he saw that Jupiter had 4 moons that were orbiting Jupiter and not the Earth, and that there appeared to be phases of Venus, which illustrated that Venus was going around the sun and not the Earth. And all those things together kind of brought about the change. The Catholic Church gets a worse image than it deserves, although it deserves a bad image. I'm not saying it deserves a good image at all, but they were trying to control how this came out more than they were trying to keep it from coming out. So they were trying to give the theologians time to catch up with the mathematics, and that's why they did things like put Galileo on house arrest. Now, I'm not justifying them at all. I'm just trying to say they weren't trying to keep this out forever. They were just trying to backpedal and catch up with information before they. I think he explains that Lycia in his book. I do not remember his exact explanations of why he wanted to do the switch, but I think that he was definitely looking at some of those things that we looked at earlier. And even some of the ancient Greeks had proposed the idea that the sun was the center and not the earth. They did not hold the majority of the positions in ancient Greece, but they were a sizable minority whose writings and thoughts have came down to us in things like the Alchemist and other Greek writings. So that there's a tradition of people who were pushing for the sun position all along. And I don't remember any more to tell you than that, but I hope that at least gets you going in the right direction on your question there. Yeah, he certainly had a lot to draw from, and it comes out with our telescopes and much better ways of observing the heavens that he was closer to being right. Of course, the real truth is that the sun's not the center of the universe either. You go to the galaxies, and the center being something nebulous that we don't necessarily know as much about, but it was the beginning of the shifts. But there's so much that they did learn with what they had that it's absolutely amazing. And through working with things like the gnomons and the meridian quadrants, we can still, without any of our modern stuff, come up with good calendars and good almanacs. And if there were a zombie apocalypse, we could keep going with somewhat of a precision with the knowledge that we did inherit from our medieval and Renaissance fathers. Yeah, and I don't know if you remember me talking about this in the first class, but it's really different, the perspectives that different society held on the astronomy. Like the Babylonians were very meticulous recorders. We have to know precisely where everything is and precisely where it is the next day. And they were very, very good with the tools they had for gaining precision. The Greeks didn't really care about meticulous observing. Matter of fact, they wanted to do everything they could to keep from meticulously observing the stars. And so they invented trigonometry so they wouldn't have to record the positions of the stars. They could just do an equation to get to the same answer. And then the medieval Arabs and Muslims, they blended the two accounts. They kept the equations and they picked back up the observations. Now the Chinese were much more like the Babylonians. Very, very meticulous recording of celestial bodies. Then when you get to medieval Europe, again, we're like, we don't want to record all this stuff every night. Let's go back to having those charts and equations so we can take the recording work out of this. And of course, they got more serious as they got closer to the Renaissance. Yeah, very much so. Mathematical accountants versus mathematical poets. I love that. That's straight on. And the Greeks were always more maverick too, as well as the Europeans. The Babylonians and the Arabs wanted to stay closer to the theory, and they were more hesitant in the adoption of new theories. But the Greeks and the Europeans, just because we're starting with a foundational system doesn't mean we're under any obligation to continue following it. But to an extent, that was everyone, but particularly characteristics of the Greeks and the Arabs.